So, hello everyone. Uh, am I audible to all of you?
Yes, Soumya, you're audible.
Yeah. Thank
Yeah,
you,
yeah.
Rishi, sir.
On
Okay,
Lighthouse.
perfect. So, first of all, very good morning to all of you. And I hope, first of all, just wanted to check in. All are back from break. Everyone.
Soumya sir,
हाँ जी sir, बताओ.
also one thing, this is the
Mhm.
first time I am able to see you very clear, not in a cloudy. Like the face, it is glowing actually.
Oh, thanks, sir. Thank you so much, sir. So, so I hope I'm audible to everyone loud and clear. And so, just wanted to check in with everyone. All of us are back. Are there still people on break and stuff?
Yes, I am back.
Okay, okay, sir.
आज भाभी ने घर के अंदर बैठने दिया शायद.
हाँ हाँ सर. घर के अंदर बैठ गए सर.
बैठने दिया. Joke apart.
हाँ एग्जैक्टली सर. ये भी बात है बिकॉज दैट हैपेंस विथ परमिशन राइट सर.
Yes, Home Minister.
हाँ सर. So just apart, so guys, let's quickly start off. I mean, let me quickly share the screen and please let me know if it is shared to all of us.
Visible
Are
sir.
we all? Yeah, okay, perfect, sir. Thank you so much, sir. So, let me go to it. Okay, here's, I think I think the PPT is visible to everyone, right? I hope
Yes, yes.
that's perfect.
Yes, sir.
Thank you so much. And before I start forward with the things, all right, let me just turn on my tools and everything in case they are necessary. Good. Let me just do this well. So, welcome back, everyone. So let's move forward with the things which we need to cover up. So, guys, up until now, right? I mean, before we all move forward with the things, right, which we are to discuss, right? I mean, just wanted to have a quick check-in, like. I hope we all are having I mean, various of my friends earlier have taken up the session and the way like the in-depth intuition about the things, like how the things work out, especially from the programmatic standpoint, right? So I'm like I hope things are pretty like a little bit clear because obviously these things are new to us a bit, right? So things work out and stuff, right? So, but hopefully, overall perspective, right? Especially, I'm talking about that audience, right? Who are not particularly who have just come up in the data science domain and stuff. So I think more or less, I think Rishikesh sir, like you have Uma ma'am and stuff, right? So I hope we all like have a collective understanding of little bit about right what the things work out as, right? And I mean, as my friends earlier have done, right? The agenda for the session, right, is not to cramp you through a lot of jargons and stuff here, right? If I talk about, right, we'll understand and simply break it apart, right, so that we have a complete understanding of how things work out, right? So, because I hope, I think in the first session itself, or in fact, the agenda, right, which was discussed by Aziz sir, right? He mentioned that we are here how to present our thoughts to the students, right? If they ask what is happening inside, we should be able to tell that what is happening so that they have a pretty understanding of the things, right? So, to keeping those things into mind, right? I'll be showing a few codes, the execution of the code for which we are not going to talk about the code, right? But the more or less we'll talk about how the output looks like and what happens there, right? So that we all have an intuition behind the things working out and stuff, right? So hopefully that particular agenda is clear and stuff, right? Now, coming back to our pointers here, right? If I talk about, right, let me probably use this here. I'll I don't know. I mean, I won't be able to see the uh, chats and everything, but hopefully that works out fine enough. I don't know. Maybe it works out okay. So, all right. Anyway, so here's the thing, right? Up until now, I think more or less little bit whatever has been also iterated by Ankit sir, right, with earlier, right, in our previous sessions, right, where we have discussed about little bit into how the LSTM architecture and the RNNs and other things, right? So we are going in, will be little bit looking into the aspects of how things work out, right? So what I've done here is I've made up a story, okay, so that we all have an intuitive understanding of what is happening here, right? So especially in the context of right, you can see, right? I have this Ravan here. So this is the name of the topic which I've chosen, right? Ravana's 10 heads and the mind of machines. You'll understand why we are calling this, okay? So in due time, right? And but the essence was to keep an understanding of how the things work out, right? So I mean, everyone knows Ravan, right? Everyone knows Ravan, yes?
Yes.
Yes, sir. So everyone has an like yeah, one of the most epic characters in I mean in our entire history, if I talk about in the context, right? A person I mean who was like thought of as a devil, but the idea was like I get inspired by his because during his time it was said that Ravan was the most intellectual person alive of his time. How many of us know about this fact? Do we know that?
So please come
Because,
again, sir.
yeah, so Ravan was the most intellectual being of his time. Do we all know about that fact?
Yeah. Very much
Yeah.
aware about it.
Yeah, exactly, sir. So I mean, very intelligent, right? It's just that the fact is he was very egoistic and stuff. We're not going to talk about those traits, but that taking that perspective, we are going to look into something very interesting to come up in our forthcoming session and stuff. Okay, so and so that's let's move forward into the topics here, right? So there's an overall context about it, right? If I talk about the course, right, we're going to look into how machines mimic, right, especially parallel processing. I've written up quite a few number of words here. As we go through the slides, right, we are going to decode it, right, and look into the aspect there, right? So attention mechanism, you can see the word here, right? We'll look into word embeddings. We'll also talk about a little bit into positional encoding, right? We'll understand why are these things even necessary and stuff, right? If I talk about, right? And the core intuition behind, right? We're going to talk about these three things. We'll look into it, right? The queries, keys, and values, right? So let me tell you before I begin with a big disclaimer, right? To everyone, right? The transformers, transformers or has been created by humans, right? Or maybe if you talk about in the terms of the scientists who initially looked into it in the context, right? But the fact is, right? It is till date the biggest fact that even the ones who created it, to be frankly speaking, right, do not completely understand as to how it works out, right? As in, if you talk about the big of a segmentation, right? You break things apart and then zoom into the things and look into how the things or the architecture is actually working, right? It is an overall perspective. And that is why, guys, what I need in the entire series of these slides, which we are going to discuss, is for you to have a very open mind, right? Okay, keep your minds open, right? We are going to discuss about a lot of different things, right? But however, it works out in the context which we'll be discussing further, right? So let's move forward, right? So within the context of the learning objective, if I talk about, let me put this here, right? So I mean, we're going to look into these, right? If I talk about attention, neural networks, right? If I talk about the core concept, right? And because I have blend mythology into these perspective, right? We'll look into a few things so that it will be very, I mean, it will be relatively easy to sip in the contents, okay? So then if I talk about, right, reducing the n-dimensional vector, right, into a 3D space, this is one thing which I'm going to probably show it to you. Like my friend Jay also already did that in the context of the 2D representation and stuff, right? We're going to have a little bit more into the intuitive feeling about how the things work out, right? What actually it means to do this, right? If I talk about, right, we're going to break these things, right? If I talk about and understand how things are happening from what you say bottom up approach, right? If I talk about, right? So more or less, if I talk about in the context, right, that's what we're going to discuss about. Uh, sure, yeah. So this is where it all begins, guys, right? So if I talk about, right, I hope everyone is able to see this, what do you say, diagram here, right? Or in fact, it's the architecture, I should say, right? Is it visible to everyone, right? Uh, all of us, can we see that? Yes, no, maybe. Are we all
Yes,
there?
yes.
Okay, sir. Thank you. Yes. So, guys, if you can see here, right, this is the original architecture of the transformers, right? And it all started from this guy here. I think you're all able to see the rectangle, the arrow marks which I'm creating. Is it visible? Can anybody confirm once?
Yes, yes, yes.
Visible, visible.
Okay,
Visible.
perfect. Thank you so much. Yeah. So, uh, uh, I'll keep this like more into the sides of the audience as well, right? So that we can understand. So this is a research paper, right? This in fact was a research paper. Attention is all you need. A research paper which was what do you say? Like very famously came up with the context, and I think Jay also mentioned, if I'm not wrong, in the in his session, he had that word. He vaguely introduced the context there, right? This was a research paper released back in 2017. So I think you can make a note of the timeline. So the year was 2017, right? So where things all got started, right? So you can see the people here. So the paper was, what do you say? If you look into, right, the domains here, Google and Toronto, right? If I talk about CS Toronto, I think University of Berkeley, I believe. I'm not sure. But these guys, right, from Google and yeah, it's written here, right? So University of Toronto, both of the they jointly, what do you say, did this research, right? If I talk about, right, and they released this paper back in 2017, right, where the initial idea of transformers, a full-fledged idea of transformers came into picture. Okay, so I think more or less we all understand the context here, right? This is where it all began, right? If I talk about, right, and you can see the overall architecture diagram here, right? We are going to look into it, right, in detail and everything, right? You might obviously it has a lot of questions and everything, right, which you might be coming up with, but I'm just giving you an heads up, right? It all started in 2017 where with this paper, right? And do you know? Can anybody tell me what was the anyone, if you all if you have any idea about it, right? What were they trying to solve here? Can anybody tell me? Anyone having any idea in this paper, right? I mean, what was the context they were trying to solve? Does anyone know about it?
Yeah, yeah.
Yeah,
Like
tell me, sir.
how they just want to like come out of all the the historical whatever the models we have been working with the LSTM
Uh-huh.
and the RNN.
Uh-huh.
Multiple times we are just layering every time just to get perfect output. But the thing was construction of the sentence while constructing something, the GPT could not do it without any transformer. Why?
Right.
Because when
Mm.
learning with this LSTM and RNN, they used to remember, let's say, only few of the words, okay, from the past.
Right.
So with,
Right.
let's say, if I just want to provide a context like Soumya is eating biscuit with milk.
Yeah.
So you might
Mm-hmm.
be finding the LSTM only with the biscuit and the milk at the
Right.
output, but not like
Right.
the Soumya is already missed. So they just want to come out of this. So that's why they have to build this transform actually. So
Brilliant.
they have to
Brilliant.
build the the attention mechanism for
Yes,
this.
perfectly said, sir. Just like how Aditya sir mentioned about, right? And in his way of representation, he just used few things, right? Especially, I have written a little bit of a technical terminology on the right hand side. What he was referring to as this is called as the context window, meaning how much context can an RN, I mean, basically, if I say about RNN, right? How much context can it look into in the past so that it can go ahead and look into or predict the next sequences, right? So that is called as a context window, right? A window is like if everyone understands the context, right? So I mean, you have a particular like it's like a gap between two which you are basically having a left and a right side, and then basically you are sliding right. So that you go ahead and get the context about it. And I think, along with Aditya sir, I think someone else also unmuted at that time. If you would like to add up, I don't remember who, but if anyone else wants to talk about this, the earlier question which I asked about what was the paper about. Anyone else? Would you like to? Someone else also unmuted. If you want to go ahead and speak up, please feel free.
This year, the same.
Right, sir. Yeah.
Nothing. Yeah, carry on.
Okay, okay, perfect, perfect, sir. Okay. So yeah, exactly. So see, both of us, right? Both Aziz sir and Aditya sir, right? Both of us have given a nice the idea as to why it was done. Let me tell you the intention of this paper, right? I mean, they had, frankly speaking, right? They did not create this transformer thinking about the idea that, okay, now I have to do a lot of big words of, I mean, I need to do a lot of complicated tasks. Like, let's say I have a stuff, and I mean, I want to, I want to generate a lot of repetitive tasks, right? The reason why it was actually introduced, right? It was for specifically talking about it was for Google Translate. You know, the reason they created what you say the idea of transformer was the idea to incorporate it to Google Translate, right? You all remember, right? We all have that. I mean, I should probably write it here as why, right? So why was it created in the context, right? So it was basically to solve the problem of what you say Google translation, right? So I think you can understand one thing here, right? I mean, that here the idea was suppose they wanted to do the conversion from one particular native language to another, right? So how would they do that is what enabled them to work on this giant architecture of transformers. Is it understandable to everyone? So the motivation was to translate said language A to another language B. Is it understandable? It got refined afterwards. Yes, sir. Yes, sir. Please.
Sir, just
Yes, sir.
because I just lost my connection, so I just
Yes.
got from now last two lines is that the transformer is basically used to translate the complex sentences. You were saying, right?
One of the, yes, sir. So you can say one of the application of a transformer is to not to use complex to simple. Yeah, you can do that also, but to change from one language, like let's say English, to another language, let's say Spanish, or English to Hindi, Hindi to English, right? That was the original idea. I mean, when I say the 2017 idea, when the paper was introduced, right, they had no idea about anything else, right? That the transformers can be further modified into a lot of different things, right? But the whole idea, when it was initially introduced, was for the aspect of only translation. So just to go in line with you, Aman Padi, yes, you're right. I mean, it was for translating from language A to language B. Is it understandable? Clear about it, sir?
Yeah, clear. Thank you.
Perfect. No worries there. So awesome. So I think more or less we all understand this particular aspect. And by the way, interestingly, why do I say that is because let me tell you one more thing. You see this particular image here, or in fact, I always call it as image. This is the architecture. Okay, so the architecture diagram, right? I will just introduce you to one specific thing here. You see here these two things, right? There is one called as input embeddings and output embeddings here. We're going to look into embeddings and everything afterwards, right? But as of now, you can see that there are two distinct inputs. Can you see that, right? Everyone, right? You see that there are two inputs. Do you understand it? Right? So you can see in this particular architecture diagram, right, there are two inputs. Understood, right? And that is why I'm going to say that this is nothing but language A, right? Whereas this would be like language B, right? If I talk about, right? So you basically give these two things in the context, right? Okay, and you will be understanding about the encoder, decoder based stuff, right? In due time. But as of now, you can see that the inputs is, let's say, English and Spanish. So the idea is, right, obviously, but I think you can understand that there is another output here in this case here, right? I think you can understand, right? There are, I mean, basically one input and two outputs. You can see this, right? If I talk about, right? Basically, you are feeding back whatever you are getting in the output back into the input, right? So that it goes on and on in a cyclic manner. Is it understandable? This aspect, is it understandable? Yes or no? Can I have some yeses and nos, please? If anything is confusing, please let me know. Only this aspect, right? I'm not going to going inside as of now, right? But is this understandable to everyone, right? So yeah, perfect. So there are two languages. You basically do that in the context here, right? So if I talk about, right, but let me tell you what you are looking in this screen, right? Right, it is encoder decoder transformers, right? So if I talk about, right, so both where both of them happen simultaneously, if I talk about, right, so that is the kind of the transformer which you see here, right? We'll look into it, right, in the context, and that is what originally they created. So this entire thing which you see here was part of the Attention Is All You Need paper by Google, and jointly by Google and Toronto people, right? If I talk about. So I think more or less it's understandable, right? Now, so here's the thing, right? let's move forward with the context here, which I want to discuss here, right? So, I mean, if you look into right on the right, I mean, it's about Ravan and attention. You can see the two words here, right? If I talk about where we are going to merge these two things, right? If I talk about and look into how the things work out, right? But don't worry about the words here, right? We'll look into the word attention in due time, right? But you can see, I'm just going to like on this slide, right? I'm just trying to explain you why both of them have been used, right? So you can see, I mean, Ravan's 10 heads, right? What I mean, obviously, it signifies a lot of world knowledge, right? When you have more than one head, right? You're technically having a lot of world knowledge. That's what the idea is, right? I mean, just to compare the fact, right? How many of I mean, I don't know how many of us know about it, but Einstein's brain, right? It was a bit like he had a relatively larger brain, if I talk about, right, compared to other people. Like they did a biological experiment to find out the weight of his brain, right, to find out the context that, okay, one of the reasons why he's associated as very intelligent is could be because he had giant, what do you say, talking about the brain size, it was bigger compared to an average human being, right? If I talk about, right? So, generally, sometimes having more quantity, right, qualifies over having, what do you say, where you can store a lot of perspective, a lot of information about the different, I mean, about the world, and then understand it much more in a vivid perspective, right? So you can see, right? So Ravana's 10 head, signifying wisdom or deep knowledge of some topic, right? If I talk about, right? Vision, having clear sight, right? If I talk about, right? Because you have a different perspective of the world, right? So strategy, I mean, cunning plans, right? If I talk about, right, the way he came up with the context and stuff, right? And foresightness, right? If I talk about, right? So some even say that, the legend Ramayana, right? The reason why he kidnapped Sita was he knew the consequences. It was just that his ego did not admit it, right? But the whole idea was he knew the consequences, right? But what I mean to emphasize here is Ravan's head or intelligence rather than as his personality, right? Okay. So you can see multiple different perspectives or processing in the context here, right? Where each head has different cognitive faculty or meaning can perceive things in a different manner, right? So similarly, in the attention head, we are going to come to this, right, in due time, right? But the attention head looks into syntax, right? What is the syntax of the language which we are talking about, right? What is the semantics, right? How are they structured, right? Or what are the meaning? What is the meaning of the word, right? If I talk about the structure, right? How the entire what do you say, corpus is structured, right? If the I mean content, right? If I around the content, the context, right? What we are speaking about, right? If I talk about in the context there, right? So that's the whole point, right? So you can see that what I mean to say here is you can understand varied perspective, right? Understanding context, you can capture meaning of the language and stuff, right? So that's the whole idea behind, right? We are going to look into and uncover bit by bit, okay? Now, next, if I talk about the foundation or if I talk about the word embeddings, right? So, guys, I just wanted to have a little bit of an idea about like what do we understand by this term here? If anybody, well, like because we have looked into it numerous times, right? If I talk about, right, although I'm going to look into in a more what do you say, graphical perspective as well in due time just now, right? But quickly, anybody would like me to tell me what are these word embeddings? What is your understanding about it? Anyone?
Converting the
Normally it
word,
is.
Yeah. Yes, sir.
Yeah,
In,
please,
yes.
Aziz.
yeah, the same. Converting the word into like numbers.
Right. Perfect. Perfectly said, sir. Yes. So numbers, in fact, the proper word I would rather use, just like how Aziz sir mentioned, is vectors. Okay. So we'll use the word vectors, right? Yeah. Aditya sir, you were saying something.
Yeah, like relativity, we can also like say sine or cosine relativity in between different terms.
Right, right. Okay, sir. Perfectly said. Nice. Yes, exactly. So the I mean, relativity between the terms, right? If I talk about, right, how the words interact with each other. Perfectly said. Nicely said, sir. Anyone else? Maybe I'll write relativeness. Anyone else? Else would like to give a little bit more perspective on the same? No? Sure. So yeah, perfectly just like how sir both of our sirs have mentioned here, right? So I mean, just like how we all up until now we understand, right? Machines do not understand raw words. They need numeric representation, right? Some kind of a number-based representation, right? If I talk about, right? So and you can see basically, word embeddings are nothing but dense vector representation of the word trained to capture semantic relationships, right? So I think you can understand the context here, right? So I mean, I think even our sir there, right? I think Jay sir had mentioned it earlier as well, right? If I talk about in the context, right? So about the example of boy, man, woman, girl. I think Sir took the example of what you say, king, man, woman, queen, right? So the whole idea behind the context there, right? We're going to look into a little bit more into the 3D perspective, how the things work out, right? So that we understand a little bit more into the stuff, right? So I mean, you can see, right? The first inputs to the attention mechanism, right? Before we talk about in the context there, right? And in fact, I mean, you can see, right, on the right hand side, you see the embedding, right? So I have written a word called pre-trained. Can anybody tell me why have I written this? Why am I writing the word pre-trained? Anyone? You can see, I mean, word to vector representation, right, for different kinds of models, right? You have globe, right? If I talk about, do you remember the full form of globe? I think it says
Yeah,
global vectors.
global vector
Yeah,
for
yeah, right, sir.
representation. Yeah.
Perfect. Rightly said, sir. Just like how you mentioned it earlier in the session as well. Global vector for word representations, just like how sir had mentioned earlier, right? So perfect. Yeah, what I was asking is why the word pre and yeah, there's this one as well. I'm sorry. There's also this one BERT as well. So anyone knows what's the full form of BERT? Okay, let me write it down, right? So it is
Bi-direction.
yeah, exactly.
Yeah.
Bidirectional encoder representation. I mean, using, or if you say, what do you say? Using the transformers, right? Or maybe from the transformer. Okay, so that's what this summarizes up to, right? So encoder representation of using the transformers. Okay, so that is why it is called as BERT, right? By just like how you see here, right? By Google, right? If I talk about, right? Now, my question to everyone, right? So I hope everyone got the context here, right? BERT is also so these basically, these are the tools which in a very layman's language, right? These tools help you to give what you say, those what you say, vectors, right? If I talk about those embedded vectors, right? If I talk about in the context here, right? So these are the tools which help you to give those. Oh, I don't know. Did I not write it? Oh, jeez. Just give me a moment. I think I wrote it here. I don't want to use this. How do I? Erase. I don't want this. I don't know what happened. Why? Wait a second. No, discard the annotation. Let me go here and go back to this. Yeah. Let me come back. Yes. So I was asking you, why have I written the word pre-trained? Anyone would like to tell me why have I written this, right? So I think everyone understands that each of these, right, help you to what you say, help you to get word representations.
So it is like model is being trained on large corpus like Google use,
Yes.
Google News, something like that. So
Perfect. Yes, yes, exactly, exactly. Perfectly. Thanks so much, Jay, sir. Exactly. So I hope everyone understands. So the reason why we call them as pre-trained, right, is because they have either of them, like each of them have been trained on very vast, what you say, corpus of data, right? So if I talk about this has fueled up to get these numbers, okay? So if I talk about they, that's why they are not random numbers, right? So I think you can understand, right? Let me tell you one thing right here. So if I talk about GPT-3, right? So so these are also called as the what do you say, dimensional representation. I mean, these vectors exist in that dimension, right? So I think if I talk about, right, so we are going that day. Let me go ahead and quickly bring that up here directly, right? So I hope let me come back. Let's go to this. Maybe, sorry, let me open this up. uh, Vidhi, I think you raised the hand.
No, no, by mistake
Okay,
I
yeah,
raised.
okay, all right. Yeah. So, guys, let me quickly open this, what do you say, my terminal quickly. I'll show you a few things which are pretty much interesting. As I said, our intention here, okay, let me not go to this, or I should probably, I'll open it in this directory itself. This thing. Let me open this in this directory itself. Okay. So, guys, first and foremost, our intention here is, as I mentioned, right? So let me run all these cells here. Okay. So we're going to look into the context of running these up, right? And having a little bit of a better understanding as to how it works out, right? So there are a few things I'll talk about, right? Let's say talk about the quick analogies and stuff, and then we'll move forward, right? What we are looking into, okay? So you can see, right? I have, what do you say, created a little bit in the context here. You can see the words, right? As I mentioned, right? Different, what do you say? What if you are trying to, like, as of now, what I'm trying to do is I want to, what do you say? Understand, right, how a vector would look like in 3 dimensions, okay? So that's the whole idea behind here, okay? So let's look into it quickly, right? So as of now, right, I think more or less we all understand the context there, right? So you can see here there are few of the words which I've taken, right? You have man, women, king, queen, rooster, hen, lion, lioness, right? You have drone bee and queen bee, right? So I have these few words, right, which are there, right? And suppose I have just initialized with random values, okay? So this is not the exact embedding. So please do not think of it as exact embedding, right? I just want to show it to you. So you're going to have a feel of it, right? So the idea here is, okay, so let it come up. Okay. So the idea here is, I hope it's pretty clear to everyone, right? So I said I want to represent it in 3 dimensions, okay? Because 3 dimensions we are able to easily perceive, right? So this is dimension 1, this becomes my dimension 2, and the third one is dimension 3, right? So the first dimension, second dimension, and third dimension, right? So I have few points which I'm plotting right here, okay? And I'm trying to plot some analogies here, right? So let's quickly look into that aspect, right? If I talk about, right, you can see the analogies which we try to create and stuff, right? I'm not going to talk much about it, but let's look at the output here. So you can see here, right? I think more or less you are able to see the vectorized representation of the first one, which you look into, right? So you saw earlier, right? So if you look into it, right, there's this man, right, which is lying somewhere. I think you can understand this. By the way, some of you who are interested, how is it created? It's created by Plotly. Okay, the Plotly helps you to create nice interactive 3D visuals, right, over boring, what do you say, Matplotlib. I do not prefer Matplotlib much into the context, but obviously we should understand one thing here, that Plotly is the advanced library which has been built on top of Matplotlib, right? So if I talk about in the context, so basics remains entwined, right? So huge respects for the basics, but as I said, just to show up in the context here, right? So now you can see, right, there's this man, there's lion, there's king, right? And you can see the 3 dimensions, okay? So I'm saying that I'm trying to represent, let me take it as X, Y, Z something so that it is easy to visualize. Come on. Are you serious? It's very difficult for me sometimes. Yeah, okay, anyways. So you can see here, right, I have the X class where I have, you can see I'm representing royalty in the X axis, okay? Similarly, whether the object can fly or cannot fly in the third axis or the Z axis, right? And the final thing which I'm trying to talk about is the Y axis, which is whether they are, what do you say, gender, I mean, male or female, right? If I talk about, right? So you see that these things are points in space, right? Pointing to those directions, right? Everyone got the context here, right? Each of us, right? So the idea here is, right, again, this does not give me a lot of perspective, right, because I'm not able to rotate freely, right? That is why you can see that zero exists here, right? So that is why, in order to sort this problem out, let me go to the next one. This one is much more intuitive to look at, right? Where you have these planes, right? You have the X plane, the Y plane, and the Z plane, if I talk about, right? In the 3 dimensional plane axis, right? If I talk about, right? So now you can understand where these points are actually lying here, right? So you can see here, right, if I talk about, right, the rooster and bee, right, if you look into this yellow points, right, I hope it's particularly visible, not sure, yeah, this one would be visible, right? So rooster or what do you say, drone B, right? They are existing in, I mean, if I talk about, right, where the plus direction of Z, right? If I talk about, right, in the context, right, that means what? They can fly. Clear, everyone, right? I think more or less understandable by everyone, right? So that that can fly, right? That's what you're talking about in the context here, right? So in the aspect which we are discussing here, right? And similarly in the royalty class, right, wherever you see king, right, royalty class may obviously king is of royal class, right? Similarly, in the context here, you see queen as of the royal class, right? You can see that the one is being assigned to that, right? So if I talk about, right, you can see the context here, right? So I hope that's particularly understandable by all of us, right? So same way you have, if I talk about gender as male and female, now it would be better if I talk about, right, in this aspect, in this perception, you can see all 3 of them, right? King, lion, and man are lying on the, what do you say, where you have, I think, in the context of, I think it is interchanged, I believe. I'm not sure. in the context here, it is actually probably interchanged. I think it is interchanged in the context here, right? If I talk about, but however, right, I think you got the perspective here, which I'm trying to denote here, right? So you have some few values which are pointing to that direction. Is it clear for everyone? Understood, right? So this is in the three-dimensional space which we are talking about, right? Now let me move forward, right, to the next set of things, right? But obviously, as I said, right, real dimensional vectors are never 3D, right? In 3D, in three spatial dimensions, you cannot get a lot of information or a lot of context which can be which you can get, let's say, in 128 dimensions or maybe 512 dimensions. And in the case specifically to GPT-3, can anybody tell me how many dimensions is GPT-3 based on? Anyone knows about it?
300.
GPT-3, no, sir. No, sir. Yeah. So the 300 was basically the one which you remember, sir. You use GenSim, right? So for the GenSim, you use that. I think that package you use, right, sir? I've also that one here. I'll be looking into that. Perfectly said. But yeah. Thanks, Jay, sir. Yeah, Ankit, sir. You said you wanted to say something.
Yeah, I mean dimensionality for all these model, now BERT, Globe, and all GPT. I think a lot. I will say like 100, 200, like that.
Sir, yeah, you are falling short of zeros. Let me write it down here, and you won't believe the
I think
number
it's
of
very,
parameters.
very much larger
I mean, I
actually.
mean,
Yes, you are right, sir. I
no, no.
mean,
I mean, like
obviously, it
it is
has to be
more. That's
way
what I'm
bigger.
talking.
Yeah,
No,
yeah, more than, yeah,
it's a lot.
exactly,
Like,
sir. Let's see how
I'm
big, just
talking
like
about all
how
these globe and all,
Jay
na
sir
word to
said.
word globe. So these are around
Exactly,
300,
exactly.
but for GPT, it's
Around
more than.
300. Yeah, you have. Yeah, larger. Yeah, depends on what it has been trained on. For GPT, by the way, the total number of dimensions is this. The number of dimensions in which a word exists is 12,288 dimensions. That means, which is equivalent to writing like you have a vector, right? You say some, X, Y, Z, and you have a lot of it. How many numbers? You are having 12K possible numbers. That is the total number of dimensions in which one single word exists in GPT-3. Okay, so 12,000 plus dimensions. Might be wondering, like, okay, we are just like, it is very easy to see three dimensions, right? It is very easy to perceive three dimensions, right? But a number existing, sorry, a word existing in that very big of a dimension, right, is, what do you say, a very highly and that is why you remember when I started this lecture, I told you people are, even the scientists, they are not fully aware as to how the really transformers throws out an output. Okay, we can like, there are a lot of things which goes in there, right? And there are more stunning facts which we are going to come across. Okay, so how many dimensions, guys? How many did I say? I want to keep you active, so somewhere in the middle I'll just, not exactly how many approximately.
You mentioned 12,028, right?
Perfect. Oh,
So
sir, nice.
why
You
it
said
is
it
that
exactly.
much dimension needed actually?
Sir, you're right about it. Why that is, right? So, sir, I'll
Yeah.
circle back to it, okay, in just few moments, okay. So, what is so special about having that many number of dimensions? Why do you want to have it, right? So, but did you? I think more or less we all understood this analogy, right? Here, I'll circle back to it because there are a few more interesting plots which I'm going to talk about here, okay. So, but as I said, right? It's, had it been like this, world would have been very easy, right? You are representing man with three numbers, that too, 0, -1, and 1, right? Very easy to represent, right? So very easy to talk about, right? But it's not that simplistic. If I talk about it, these are hypothetical values, right? If I talk about, now let's come down. If I talk about, okay, by the way, there is one more representation which I wanted to talk about. So it was very difficult to look into the perspective in the 3D, right? So what I have done here in the third one, I think you can understand this is a 2D projection of the 3D embeddings. I think everyone could understand it. Okay. I hope everyone remembers there were three axes, right? So X, Y, and Z, right? So X axis denoted royalty, Y axis denoted gender, and the Z axis denoted whether something can fly or not, right? If I talk about, right? So what I have for simplistic representation, right? I have just, what do you say, taken that up, and this is how the word is getting represented here, right? You can see in the context here, right? So gender is equal to, what do you say, Y, if I talk about, right? You can see women are being showed up here, right? If I talk about, and you can see queen bee, women, lioness, queen, right? You can see the words here, right? I hope everyone can see that. Is it visible to everyone? Yes? All of us can see it, right?
Yes, yes, yes. Visible.
Perfect, perfect, perfect.
Yes.
Thank you so much, sir. Right, perfect. So similarly, on the other hand, you can see rooster, drone bee. Drone bee, by the way, is an exact opposite of queen bee. I mean, the male version of what do you say, female bee is called as a drone bee, by the way. Okay, so you can see that they are being represented in this axis, right? So man, king, lion, and so on and so forth. This I have created hypothetically, right? So and you would see, I mean, a striking similarity. Okay, the one which I've created hypothetically, talking about different bigger models, they have created it in a more intrinsic view. If I talk about, right now, same way you can see gender versus can fly. This is one particular column. You can see can fly on top and the gender on the x-axis. You can see lion, king, man, right? All of three are, and you can see they obviously cannot fly. Similarly, women, queen, and lioness, they also can't fly. And that's why they are in this particular axis. Whereas you can see drone bee and rooster, right? If drone bee, rooster, and similarly you have queen bee and hen, they both can fly. But you can even see that gender is also separated. All good, everyone? Just to show, I just, what do you say, used a hatoda, what do you say, or you can say, I mean, I used a hammer and just made it flat to show it up, right? It's very easy to talk about, right? Now, if I look into this, royalty versus can fly, you can see that in the context here, right? You have hen, rooster, queen drone, and bee drone, right? So I think you can understand that this is how the things work out, right? If I talk about, right, women, man, lion, and stuff, right? Whether they can fly versus royalty status, right? If I talk about, right? So I think you can understand the context here, right? Even, I mean, the king of the jungle, lion and lioness, they both also have a royal status, right? I think that's why we call it as king of the jungle, right? If I talk about in the context, right? So that's why you can see half of the, I mean, just giving some kind of weightage to that, right? If I talk about, but I think everyone can see that there is one thing which is missing, right? So, I represented, everyone agrees to one point here, right? My actual representation was in 3D. Okay. Everyone understood? My actual representation was in 3D. I am representing the same thing in 2D here. I'm trying to represent in different perspective, right? But did you notice one thing? When I'm trying to capture gender and royalty, I'm not able to capture can fly. A dimension, I'm not able to capture it here. I hope you can understand, right? If I can only capture it in 3Ds, the complete perspective can be captured only in 3Ds. But we can do some kind of transformations, right? Like so that we can also capture those information bit. But let me tell you one thing, even if you try to capture 3D in 2D, right, in a 2D graph, it will still lack a lot of information because you are still trying to sandwich, no doubt about it. Just because you sandwiched it does not mean that it forgot the complete context. You're trying to sandwich it, right? So what I want to tell you about here is big star point. Okay, when I'm doing this, I'm trying to represent, if you try, so it is possible to represent 12,288 dimensions back in 3D as well. I can do that. But the information loss in the process will be huge as well. That cannot be visualized by us because our mind is capped into understanding three-dimensional context only. Understood, right? Everyone got the perspective which I'm talking about here, right? You can do some ounce of it, right? You can obviously take the patterns, extract patterns and understand it, but nevertheless, it is not. And that is why I want to come to a point where Jay sir had mentioned in his lecture, right? Where he had talked about that, he said that if we talk about, like, let's say, queen, king, and let's say man and woman, right? And you do the operation, right? You say he had already mentioned it, saying that the relation is not exactly similar, but very much somewhat similar. That is the word which he used. And that is what I want to reiterate here again very clearly. Why? Because the more you lose the dimension, the more information you also lose as well. You do transformation, that is correct. I am not denying that, right? But it won't be completely accurate in the representation because my mind or any of our minds cannot perceive a dimension of 12,288 in practice, right? Mathematically it might be possible to talk about a little bit, right? But again, you know what you do is you convert it to something called as a lower rank matrix. A very higher rank matrix is converted to a lower rank representation of the bigger representation. Do you understand, right? So that is what do you say, calculus jargon, which I just used, right? So what basically you are doing is you have big dimensions, you are just sandwiching and sandwiching it further to gain, you are putting it into perspective. Got it, guys? Everyone understood, right? I hope that's particularly clear for everyone. All right, now that we have understood that fact, I don't know why this thing comes up always. No, so, yeah. Now, let me go to, okay. I think everyone understood. I'm not going to go into the crux behind all of these things, the codes and stuff, right? Let me go directly to something more interesting here, okay? So now that you have understood the previous perspective a bit, right? So whatever we saw, right? In the context of word, how it looks like, right? Here, you get an idea of the Gen Sim, right? If I talk about, you remember Jay sir being using that, right? If I talk about specifically the model which Jay sir used was Glove GigaWord 300, if I'm not wrong. Was it correct? Am I correct, Jay sir? Is
Yes,
that correct? Yeah, exactly. So he used the model called Globe Wiki GigaWord 300, right? That means basically a representation of a word in 300 dimension. Correct? A representation of the word in 300 different dimensions, right? So just like how sir had mentioned, right? In the context here, if I come back here, you remember, right? I have used this word here, right? The embedding types, under that, you can see the word globe here, right? And I have written the word as pre-trained, right? In the PPT, right? Let me come back here in the context, right? You can see here, right? So this I'm using, what do you say, globe 50. Basically, I think everyone understood, right? What is this doing? It is representing a word in 50 spatial 50 dimensions, right? If I talk about, right? So just like how we discussed about earlier, the dimensions were not much here, right? But now I have more flexibility. I am representing the word in 50 different dimensions. Cool. Everyone understood the concept here, right? So now, and by the way, that is why I've written here the word here as pre-trained, because the numbers which you see here, right? These number or numerical representations, right, are existing in 50 dimensions, right? If I talk about, right? So let me use this. Let me just talk about. I hope everyone remembers the LEN, right? You can see that just like how we talked about, right? This matrix exists in 50 dimensions. Cool about it? Everyone got it? Yes or no? Right? Perfect. Brilliant. So nice. But now you can see that there is these arrays, right? So these are all in 50 dimensions. So imagine imagine there was a model here called as what do you say, something like GPT, what do you say, GPT-3 or maybe 3, right? In that case, the model, if I portray tower, can anybody tell me how many dimensions will it have? Had there been some model like GPT-3 there, so what will be the number of word representations you get? How many? Did we all
12.
get it? Yeah, 12K. Exactly, sir. Right? Just like how you said it, right? 12K, right? Because I just said that 12,288 is the number of dimensions. So even that big of a number would be like very huge, right? So the idea is that, right? So that is why you can see even this is giga word, right? I mean, it's a very, what do you say, big if I talk about. And imagine 212K. I mean, it's like out of bounds in the boundary of the even in the remotest boundary of the mind, it does not click up, right? But that's the truth about it, okay? So that's the whole point, right? Now, what I'm doing is I'm trying to represent the word tower, right? So let me come back here. Now that you understood the fundamental aspect, right? What I have done is, see, let me go to the aspect here. Okay, just to give you a quick aspect here, right? To understand what is going on. Okay, so obviously Plotly is being used, and you are using this. Can you see this? I have imported PCA. Can anybody tell me what is PCA? What is PCA? Is anyone?
Principal component.
Principal.
Yeah, principal component. Yeah, right.
Analysis.
Yeah, exactly. So if I talk about, I think you can understand, and that is why you see that this guy PCA actually exists within a package, within a sub package of sklearn called decomposition. Decomposition is like you, what do you say, reduce something, right? The word decompose means to reduce something, right? That is why I think you can now understand what is whatever the code is doing, right? I have imported something called as PCA, and the direct implication of PCA is for dimensionality reduction, meaning I want to reduce the number of dimensions from a very huge like 50, okay, like 50 to name, I mean, to basically something which can be visualized, like let's say 3D. Got it, guys? Everyone, easy enough to understand the perspective, right? So that is what the PCA is doing here, right? And apart from that, there are the things which I don't want to iterate. So I think you can understand I am representing the word tower, and I have in the form of 3D, right? If I talk about, right? So let's move to that, okay? And understand what is going on, right? So you can see here, right? You saw earlier that there were 50 dimensions. Sorry, the word tower had these 50 dimensions, right? If I talk about, right? So this has been reduced now to only 3 dimensions, right? And if I talk about, right, that is how I'm able to represent in the 3 dimensions, or the, you can see, right? Can you see the here? Can you see here? They are, these dimensions are even called what do you say, called as PCA 1, 2, and 3. The main primary component, the 3 primary components. So if I were to say, so you are basically asking the question as, if I want to reduce the thing, reduce 50 numbers to just 3 numbers, what are the most primary aspects will you consider out of those 50 numbers, is what PCA is doing. Hear about it? As a very simple aspect, right? Because I know there are mixture of audiences, right? That's why I'm just focusing on the basics here so that we understand. The idea is now 50 is reduced to 3 dimensions. Got it? Understood? Something in that brain is happening and stuff, right? And it reduced it to 3 dimensions. And once I do that, you can now see that this tower, right, is, you can see there are some numbers there, right? It shows me, right? It shows me like 1.09 minus 0.56 and Z being minus 1.33. Can you see those numbers? Is it visible to everyone? Or am I the only one seeing it? I think I'll be able to show it now. Is it visible? Perfect, perfect. Yeah.
Yes.
So these, yeah. So after doing that Tigdam magic stuff, in principal component analysis, that 50 dimension has now been reduced to 3 dimensions, and these are the numbers it gets. And this is for the representation of the word called tower. Okay. So more or less, I think it's particularly clear for everyone. So it is represented in 3 dimensions. So you can easily have a view of it, right? If I talk about, right? Now, let me go to the next. Okay. So in this case, I think now you understood, right? You did that for one, right? Earlier you did it for one of it, right? Tower, right? Now I'm doing the same for these few words, right? Uncle, woman, man, girl. You can see, I mean, I think I can show you here, girl, boy, or aunt and stuff, right? You can see, right? These are the various vectors, right? I think I can show this perspective. It will be easy to look, right? Yeah. So you can see there are these, right? I am representing woman, man, uncle, aunt, boy, and girl, right? If you look into it, right? So everyone understood, right? But you should understand each time when it is doing it, right? It is first existing in 50 dimensions. That gets reduced to 3 principal components using the PCA, and that get represented here as a vector. समझ आ गया सबको? Clear about it? Yes or no? Right? And what I want to focus more here is, look at this, guys. Here, if I talk about the distance, right? You see women, man, right? They're very much near to each other, right? It could have been possible, right? It is a 3-dimensional space, right? This line could have existed somewhere else as well, right? There are 4 quadrants. I mean, sorry, not 4. There are three axes. That means 8 quadrants, right? It could have existed in these quadrants as well, right? I think you can understand, right? But it is still, these are, I mean, they are closely intact with each other, right? Can you see this, right? I think you can understand that what I mean to say here is man and women are existing here, right? If you talk about boy, girl, again, they are very close to each other. Again, uncle, aunt are existing close by to each other. Can you see that, right? And that is all coming after whatever the actual representation it has learned after training from lot of huge corpus, right? So it crawls through the entire internet, gets all the data, then represents the whole point. I mean, okay, these are the associations I can make. So it's, it asks a few questions before doing it, right? That how many dimensions am I able to, like, am I given a flexibility? For GPT like model, it says, no need, don't care about the dimension. I have huge number of it, like 12K. If the dimension is 3, it will be constrained to think very, what do you say? It would be very, what do you say, constrained towards the entire space, because obviously, no doubt, it is correct that in each of the space there exists infinite number of points, right? But to visualize those infinite number of points literally is a very big challenge, right? If I talk about, because they will be very, right? How many numbers are there between 0 and 1? How many numbers are there in between 0 and 1?
0.
Infinite, right? Basically, that's the whole point, right?
Sure.
So if
If you're talking about whole numbers, it will be 0, right? And
sir, you added
decimal numbers.
perspective there. Yeah, exactly, sir. Okay, sir. I mean, how many natural numbers? I should say natural numbers. I was wrong about it. So how many natural numbers are there? So the answer would tend to, like, obviously infinite, right? Again, if I ask you the question, how many numbers exist between 0.1 and 0.2? Obviously, that also turns out to be infinite, right? But if you look into the scale, right, it is very difficult, right? Obviously, there can be a number like 0.1, I mean 100 zeros and 1, right? And then there will be a number between 0.1, 100 zeros and 2, right? But representing them will, I mean, it will be like a clutter to, you won't be able to think about it, right? In the perspective, you can sandwich it. It is possible to sandwich. I'm not denying that. But on the process, it will, I mean, it does not have a lot of flexibility. Do you get it? So did we all understand why more dimensions are necessary? Is it understandable? So that it understands, it has rich contextual meaning. Got it? Everyone got the context and understood the perspective here, right? So I hope it's particularly understandable here, right? So this is what I wanted to talk about, right? Women, man, uncle, aunt, right? You can see they are very close to each other, and the vector representations are also very close by, right? Similarly, now in this next perspective, what I am trying to do here, right? I'm trying to solve that analogy which we discussed earlier, right? So you have this women man analogy, right? So it is spread. I mean, you can see there is a wedge here, right? Is it visible to everyone, right? I think it might be very little bit difficult, but still, can you see the wedge here? There is a wedge which says girl here, right? And then there is, if I talk about, right, there is the actual point called girl, right? If I talk about. Can anybody tell me what am I trying
Yes,
to do
yes,
here?
yes.
Why are there 2 points here? Yeah, yes, sir. You were saying something, Ankit, sir.
No, I mean it's visible.
Yeah, perfect, perfect.
I
So,
don't know what you are actually trying to do here, but it's
yeah.
visible. Girl and
Actually,
woman equal to girl, like that.
Huh. It
Or
is
woman
visible,
girl,
right?
what?
actually,
Yeah,
now both are not same here, but little
huh.
bit matching.
Exact.
Little
So
bit
just
difference.
to, yeah, exactly. Perfectly said, sir. You're right. The red color here is the position of actual girl in the word corpus. If you compute it through PCA, right, the red color point is the actual point where I mean which you get in the context here, right? If I talk about, right? So no, sir, I interchanged it. I'm sorry. Yeah, I mean, in the context here, right? If I talk about, right? So here you have the girl point here, right? It's the actual one, but the one which you see here, right? The point girl here, right? This one, right? If I talk about, right? This, if you look into, right? Actually it is the other way around. Okay, this is the actual girl point in the what do you say, PCA, right? Through the PCA, but this is the calculated girl point, right? How did I calculate it? Basically, the analogy which was used by, what do you say, Jay earlier, right? Boy minus man plus woman, right? So I take the vector of boy, which is existing here, right? If I talk about, right, there's the boy's point, right? If I talk about minus man, right, the vector point of man, and adding woman to it, right? You can see that it is relatively close. Can you see that, guys? Right? And just to show it to you, why am I saying relatively close? Let me show it to you what I mean by that, right? If I hover over here, by the way, guys, I'm bad at remembering things. So let me just probably use this. Oh, it does not show it to me. Guys, can you help me remember it, by the way, anyone? This girl point here, look at the coordinates. I want you
Show
to
me,
focus on the, yeah.
show me the
Uh,
coordinates, na?
yeah, exactly, sir. You kept it in
Yeah,
mind, sir?
this that is in red, na?
Correct, sir. Did you
Yeah,
keep it in
I'm
mind?
sharing
Yep.
in the chat.
Awesome, sir. Thank you.
I will keep in mind.
Okay, sir.
Yeah, keep
Awesome.
in mind. I also share.
Shared also. Perfect. Thank you so much. Now let me go to the girls' coordinate here. Let me just hover over here. Arey yaar. Do you see something similar here?
I think X is similar. 134
Yeah,
minus 134.
right, sir. Minus
Point
136.
01 difference is there.
Right, exactly, sir. Exactly.
Yeah.
You got, yeah, right. So what, yeah, bottom line is perfect. Thanks for the intuitive stuff. Thanks for helping me out here. So the idea here is pretty simple here, right? I think now you can understand the way the vector representations have been created, right? They are very much close to each other. And I told you, remember one fact I told you, while doing reduced I mean, when you are reducing the dimension, still you are losing some information, right? And still there is an approximation, right? But on the overall scale, if you look into, right, it is still okay in the context of the stuff which we are discussing about here. Is it understandable by everyone, right? I hope we were able to establish the fact here, right? That the vector representations are very close to each other, if not exact matches, right? That does not, we don't have to care about it, but as long as they are, because anyways, right, it is all probabilistic. So I think you can understand the probability of this particular point will be a little more compared to the other, right? And that way, even after doing soft max and everything, we'll talk about that, right? You'll pick up the right word. What I mean to say is this: is it understandable? Clear about it, right? How things work out, right? And we are going to look into those contexts there as well, right? And this is the final representation which I wanted to just show it to you. This one, what I did is I also put some, what do you say, angles here, right? If I talk about, right? So you can see, to see the angles between these two, you can see the man and woman angle, right? It exists in almost like 6.34 degrees, right? You can see, right? We have created angles here, right? You can see this, right? And I think more or less you can play around with it, right? To talk about, and you can see, guys, look at this. Look at this very interesting aspect. Time of taking food, right? Breakfast, lunch, and maybe dinner, right? So if I talk about, right, you can see these two words close to each other, but dinner, can you see this? Dinner is somewhere else, because you might see some of the words going away from the context, right? There is a reason for it, because these words can be frequently clubbed up with a different meaning. Okay, guys, I'll take few more minutes, okay, if it is okay for everyone, and then I'll wrap it up here. Okay, is it okay? Few more minutes, is it fine to everyone? Maybe let's say
आदित्य सर से पूछ
Yeah,
लीजिए
yeah,
एक बार.
okay.
3-4 more minutes, sir.
Yes, yes, Soumya, we know
So
that.
morning
We know
itself,
that.
our like we have fixed up. If it is your session, there will be extension.
Obviously,
Yes, you
we
can
know that.
continue.
Yeah, continue.
I just want to give you a complete perspective. I'm sorry about that to everyone, but yeah. So
All
thank you
going
so
good.
much.
Please continue.
Yeah, thank you so much, sir. So thanks for that. So guys, look at this. You have lunch, breakfast in the same direction, right? Whereas if you talk about, right, I mean, I have dinner somewhere on top. You can see here, right? You can see this, right? So, but overall, right, if you talk about it, still in the same direction. If I talk about, right, as long as you remember, right, what do you say? Jay had mentioned earlier, right? The If I talk about the cosine similarity, if I talk about, as the angle is smaller, the more that you can see that this is what you say. They are more relative content. If I talk about, you see that the angle is 6.34 degrees. If I talk about, right, as it nearer to each other, if I talk about, the vectors are very closely to each other, and you expect a positive outcome. Okay, I mean, as of now, you can think of the sign as being a big plus sign. If it is 0, that means it will be big plus sign, right? But as it goes in the opposite direction, right? So if there is a turn in the 180 degrees turn, right, that means there is in the opposite end of the things, right? If I talk about, right, so in the context there, which we are referring to in the context here, right? So the idea here is pretty straightforward. If I talk about, right, you can see that these three words are represented in the context which we are talking about here, right? Now let me just come to this, right? There's a few codes here. I don't want to talk about the code much, right? You saw that I used few of the codes, right, for these, right? Man, women, boy, girl, breakfast, lunch, dinner, right? Sure. And there is a pattern to it, a very interesting pattern to it. Let me show you. Okay, I'll add some more words here. Okay. By the way, the total vocabulary, right? The number of words this globe has been actually trained on is, let me show it to you here. It is close to, I think, I'm not sure. Yeah, can you see this? The vocabulary size is 400,000. That means 4 lakh words. It has been trained on 4 lakh words. Okay, the vocabulary size of this model. Okay, and that is why it is called as, like, they have used a giga word, a fancy word, meaning a very giant word, to show up the stuff. Did we all understand what is vocabulary size, by the way? The words, individual words like on, at, the, maybe dinner, shoe. Did we all get it? Is it understandable? how many such words it has been trained on?
Yeah,
It is
unique
4.
unique words.
Yeah, exactly. Thank you so much, sir. Exactly. It has been trained on 400,000 or 4 lakh unique words, English words. Okay. So now that means it has it has a lot of words to talk about. So if you have some words in your mind, you can spit me out. I'll write it here for the context, for reference. Okay. But I have some. Let's say maybe I'll use the word one. I have two. Let's
Lunch.
say. Uh-huh.
Add
Sorry,
add
sir.
lunch.
Lunch. Yeah, exactly. Lunch I have added, sir. Here it is already there. Lunch. Any
Okay,
other
okay.
words you want to see? Let's say
Break,
tree. Sorry, sir.
break.
Uh,
We can add.
brick. Yeah, brick.
Snacks.
BRICK. Snacks. Okay. SNA. What is the spelling? CKS. I think, yeah, that's correct.
Yeah,
That's
correct.
right.
And maybe snack. SNACK. Okay. I'm deliberately putting these things. I think you can understand what I'm trying to do.
Snake.
4. Snake. Okay, nice, sir. Awesome. So a few, one or two more words, maybe. That's it. I'll do.
Anaconda.
Anaconda. Okay. Yeah, perfect. Okay, let's do this. Let's have a look at few things. Awesome. Now, interesting enough, let's have a look at the things. For the time being, what I'm going to, you saw the earlier embeddings, right? So I'll do one thing. I'll remove these guys here, right? So that, okay, no, let it be, because there are some codes which are very much. Can you see one thing here? As if I talk about, right? Look at this one pattern which you can think of. What can you get as a pattern here? You see this cluster here? What do you think?
Numbers.
Numbers
Yeah, exactly,
are
sir. These
nothing.
numbers are getting, yeah, they are actually being, in some kind of, they are somehow orienting in the same kind of a direction, right, sir? Exactly. Perfectly said. Similarly, if I talk about, right, can you see this here? The word snack and the word snacks, right? Both have the same kind of a meaning, right? If I talk about, right, they are lying almost near to each other, right? The plural forms, right? If I talk about, right? So if in the context, right, you have brick here. Can you give me a similar word to brick? Anybody give me a similar word to brick?
Sand.
Sand. Okay.
Rock.
Maybe you use sand to create bricks, right? So maybe I'll use sand. Yeah. Anyone else had some ideas?
Stone.
Stone. Yeah.
Wall
Okay.
Rock you
construction.
can add.
Stone.
Stone you can.
Cement.
Okay. Cement. Yeah. Okay. Nice. Okay. Nice. That's great. So we have few words now. Let's represent that and see what the model comes up with. See, cement is in a very different direction if I talk about, right, the actual word representation, right? Because I think it might have studied cement in different contexts, right? A concrete cement or maybe Ambuja cement or maybe somewhere. Because these things are trained on a lot of different words, right? If I talk about, right? So the whole idea is, right? But what all other words which we took? Do you see them? Where is it?
Stone you have taken.
Yeah, stone. Yeah. Yeah, perfect. I think brick, sand. Can you see this?
And
We have brick, sand very much near to each other, right? Stone is here, right? If I talk about, right? But there are clusters getting formed, right? What I mean to say is there are clusters getting formed, right? If I talk about, right? Everyone understood the concept behind which I wanted to show up here. It will not be exact, never expect it, because there are patterns which we as human beings are only limited to a very limited context because we can only perceive in 3 dimensions. Okay, these guys on the other hand have been trained on 50 different dimensions. They think like, I mean, if that is the reason, you might have seen some big news coming up saying that AI has become sentience, right? Or maybe AI is creating its own language. How is it able to do that? Because these guys are existing in that many number of dimensions. They come up with so much refined understanding of the world, which we even might not come up with. We created a language to interact, right? We not knowing the full potential of the language, right? But AI, on the other hand, especially these transformers mechanism and stuff, right? As we go in higher dimensions, right? It can think in many different perspectives, which we may not even associate with, right? Because we generally think that, okay, this comes up with the idea of this notion, right? So this is what I wanted to talk about, maybe in the context. I hope we all had interesting what do you say, session. I wanted to complete it, but sadly I